Hello my dear friends, how are you? I hope that your preparation is going well on track. Welcome to IMS Gate Academy. I am Sourav Upadhyay, and in this session we are going to have the power packed session of questions on a very important subject of mechanical, that is heat transfer. My dear friends, you know that heat transfer is going to come for an average of 6 marks, 6 to 5 to 7 marks I would say, considering it's not 5, it will be 6 to 8 basically, anything between 6 to 7 I can say. Last year it came for 8 marks, and these are some of the scoring marks my dear friends. Now scoring in terms that relatively easier to score as compared to we can say FM, or we can say some tougher concepts from vibrations. So comparing that, you can score a bit easier in this section, and that too only with 4 chapters. Yes, only 4 chapters. What? Conduction, convection, heat exchangers and radiation. So that is one of the very good profit cost to benefit ratio in your entire mechanical engineering when it comes to this subject. So what are some of the good cost to benefit subjects which you should aim for Gate 25, like HT, like industrial, like engineering maths, then we can say SOM. All these subjects are relatively, you will feel easier to score as compared to other subjects. So you should never miss out on these subjects. It doesn't mean that a tough question cannot come in these subjects. It only means that you should at least do these subjects, as it can get you some easy marks. So my dear friends, what we are going to do in today's session, you know that last week I have taken a gate score booster session on your industrial engineering, and you can clearly see that all the best questions with best concepts, a slightly higher level I have taken. You have watched also. If not, you can go and watch it again. And today I am going to do the same thing. I have taken some of the best questions my dear friends on the subject heat transfer. So even if you have completed 80%, 90%, you are suggested to watch the session. And what you are required to do, I will be displaying a question over here. I will give you some time, 3 to 4 minutes to solve. You will be needing to sit with your calci and a rough paper. You will solve in that time, and after that I will be solving it, right? So yes, good evening Mathan, good evening Ashok, Yashwant, very good evening. So I hope you are ready, and now without wasting any time, let us straight away get to the job. So here comes the first question my dear friends. Here comes the first question. Okay. So did you solve, any one of you? So what this question is saying, the question is saying a hollow sphere of inside radius 3 centimeter and outside radius of 5 centimeter is electrically heated at the inner surface at a constant rate of heat flux of 10 to the power 5 watt per meter square. The outer surface of the sphere dissipates heat to the surrounding air at 40 degrees centigrade. Assuming K is equal to 15 watt per meter Kelvin for the sphere material and H is 400 watt per meter square Kelvin, calculate the inner and outer surface temperature of the sphere. Okay. So let's say what this question is saying. The question is saying that this is an inner sphere and this is, concentric spheres are there, hollow sphere, of inside radius. Okay, so let me consider this the hollow sphere. This is the hollow sphere and the inside radius is 3 centimeter and the outside radius is 5 centimeter. Okay. Is electrically heated at the inner surface. So I am assuming that the inner surface is at a temperature of T1 and at a temperature of T2, and since it is heated at the inner surface, so temperature will flow in which direction? From the inner to outside in the radial direction. The heat will flow. The heat will flow from inside to outside. Okay. And heat flux is given as 10 to the power 5 watt per meter square. The outer surface of the sphere dissipates heat to the surrounding. Now surrounding air is maintained, that is T infinite is maintained, is given as 40 degrees centigrade. Assuming K, so K of the material, this is the material you can see, this is the material which I am shading, this is the material. So K of this material is given as 15 watt per meter Kelvin for the sphere material, and H, so heat transfer coefficient is given as 400 watt per meter square and Kelvin. Calculate the inner and outer temperature of the sphere. So T1 and T2 he is asking you to calculate. T1 and T2 he is asking you to calculate. Okay. So see my dear friends, it's a very good question and it's based on sphere. Now why I have taken this question? Because generally sphere questions you will not see these years, recent years. So there is a good chance for this. Okay. Now one thing is there, I know the heat, this is the heat flux. So total heat can I find out? Total heat will be heat flux into area. Now which area? Inside area, because it is generated at the inside surface. So 10 to the power 5, and what is the area of the sphere? Surface area 4 pi r square, and r square is 3 centimeter, so 0.03 square. So when you calculate this, the Q value you will get around 1130.97 and watt, 1130.97 watt. Now I know the heat and it's a case of steady flow only, and even if it is not mentioned you have to assume steady. So steady flow is there, so same heat is traveling. Now what should I apply? How I should get the value of T1 and T2? Then so first I will go to the go to the outside surface. So at the outside surface, what I can say? At the outside surface, I can say that whatever is the Q, that I can say HA delta T, HAS and delta T. Q I already know, that is how much? 1130.97. 1130.97. H value they have given to you, that is 400. And what is the surface area of the outside? 4 pi, but there the radius is how much? 5 centimeter. So 4 pi r square, that is 0.05 meter whole square, and delta T would be from surface. Surface I don't know T2, but ambient I know, and ambient is how much? 40 degrees centigrade. So from this equation I can very well get the value of T2. I can very well get the value of T2. If you solve, you would get around 130 degrees centigrade. So I'm not wasting time putting values in the calc and checking, that you do, but I'm just telling the concept. So T2 we will get around 130. Now how to get T1? T1 I can very easily apply the heat equation for the material of the sphere. So what do we know? That delta T is equal to Q into thermal resistance. Delta T will be what? That will be T1 minus and T2. Q I already know, that is 1300. I know this. And what will be the RTH? So RTH value will be what for the sphere? Thermal resistance for the sphere will be R2 minus R1 by 4 pi K R1 R2. So R2 is how much? 0.05 meter minus 0.03 whole divided by 4 pi K. So what is K? K value is 15. That is 15 into 0.05 into 0.03. So we will get the thermal resistance of the sphere. You know already Q, you know already T2. T2 is 130 degrees centigrade. So all these things you know except T1. All these things you know except T1. So if you substitute the value, you will be getting the value of T1 also. If you substitute the value, you will be getting the value of T1 also, and T1 you will be getting around 210 degrees centigrade. T1 you will get around 210 degrees centigrade. So is the concept clear? Is the concept clear? How did we solve the question? So it's a very good question, and the entire concept of spheres, conduction in spheres, would be cleared through this question. Okay. So he asks the inner and outer surface temperature of the sphere, and that we able to find neatly. Chalo. So I hope that there is no doubt in this question. Moving to the next question. Before that, my dear friends, let me tell you that this is the time when you should practice a lot. And how to practice? There is no better way than to give the test series. So we are here to give you 20% off on our test series plus product. What is that? Let me quickly brief you. In normal test series, if you buy, you will only get the test series, that is the 130 plus test series. But when you buy test series plus, not only the test series you get, but also along with the GQB booklet also you get. And let me tell you that it is one of the unique booklets of GQB that we have, that is the gate question bank. GQB means gate question bank. All the previous years solved, and two books you get, one of the core branch and another of maths aptitude. And when you see the solutions, you will see many questions solved whose video solutions are also provided. Alternative solutions, multiple solutions are there. So if you buy now, you will be getting 20% off, and let me tell you that it is a limited time offer. Okay, and for any such queries, please, link in the description is given. Please click and talk and have your queries resolved. Okay, so quickly let me brief you what about the test series plus. Online test will be there, yes, and 33 years gate question booklet will be there. Now why this is important right now? Because question practice, now is the time you should practice a lot of questions, and already you are getting the tools to practice questions. Okay, and along with that, doubt solving portal also you get. In case you have any doubt, you can ask. Online revision score booster you are already getting. Post gate guidance also you will get in case you get decent marks. Mock interview, all these things are there. My dear friends, if you want to join the live online program for 26, you can very well join it. Where 800 hours of live classes will be there. Theory book, exercise book of 4000 plus questions will be there. GQB will be, you will be getting one-to-one, you can interact with your faculties, and online test series you will also get. And for any doubt, the link is there in the description, or you can call on this number below. For any query, do get it resolved. Okay, chalo, let's go on to the next question, and I would start the timer. So let me tell you what is the question saying. A square plate heater 15 centimeter into 15 centimeter is inserted between two slabs. So two slabs are there and a square plate heater is inserted between them. Slab A is 2 centimeter thick with conductivity of 50 and slab B is 1 centimeter thick with conductivity of 0.2. The outside heat transfer coefficient on side A and side B are 250 respectively. The temperature of the surrounding is 25, and if the rating of the heater is 1 kilowatt, find the maximum temperature of the system, assuming steady state flow. Okay. So let me explain you this question. This question is saying that there is slab, A, which I have drawn, and there is slab B, and in between them there is a heater, in between them there is a square heater which is inserted. This is the square heater which is there. This is the square heater which is there. This is the heater. So let me show you the coiling so you would understand that this is the heater. And what is the cross section? Cross section is 15 centimeter by 15 centimeter. So I can say that area, I can say 225 centimeter square, or this is 0.0225 meter square, I can say. To slab A is, so let me assume that this is slab A, and let me assume that this is slab B. That is 2 centimeter thick. Slab A is 2 centimeter thick, and slab B is 1 centimeter thick. On side of A, the environment is having a heat transfer coefficient of 200, and on side of B, the environment is having a heat transfer coefficient of 50. The temperature of the surrounding is 25. What is the temperature of the surrounding? 25 degrees centigrade, and it is present on both the sides. On both the sides, this ambient temperature is present. It is present. If the rating of the heater is 1 kilowatt, so already he has given that heat is being produced at the rate of 1000 watt at the center. At the center, it is means exactly in the middle, not in the middle, but in between them, the heat is generated. So find the maximum temperature of the system. Find the maximum temperature of the system. So my dear friends, when this is the source, when the heater is the source, so some heat naturally, some heat will flow over on the left side, and some heat will flow on the right side. But will it be same? No, I cannot say that it will be same, because the materials are different, conductivity is also different. Material A is having a conductivity of 50, and B is having a conductivity of 0.2. So I cannot say that both are, same heat will be transferred. It will be unsymmetric. But if it was symmetric, we could have told, if both the materials were same and exactly in the middle it was placed, so I could have told that 500 and 500 it would have been flowing. But this is not symmetric, so different heat is flowing. Let's say on the left side it is QA, and on the right side it is QB. Surrounding air temperature is given, and find the maximum temperature. Okay. So what I can say is that QA plus QB will be equal to 1000 watt. QA plus QB will be equal to 1000 watt, and he is asking the maximum. So one thing is clear, that wherever is the heat source, from there the temperature maximum will be there, or the heater itself will have the heater surface itself will have the maximum temperature present. That is the, let me assume that this is Tm. I am assuming that the heater is at Tm. Slab, I can assume that A side, the slab A is having the surface temperature of Ta, and slab B is having a heater, the surface temperature at Tb. Okay. So how to proceed in this case? So I will be finding what is QA, and I will be finding what is QB, and both things I will be putting it over here, and then let me see whether I can use this equation 1 to solve the equation or not. So what will be QA? QA will be, I can say that T1, I have assumed what? Tm. So Tm is the maximum temperature minus, now I will not write Ta, I will directly write the infinite, T infinite, because I know I should know something, either both will be unknowns. So Tm minus T infinite, and in between whatever resistances are there, so L by Ka, so La by Ka into area plus the convection heat of 1 by Ha, 1 by Ha into the area. So Tm I don't know, and infinite is what? 25 degrees centigrade by, what is LA? 2 centimeter thick. So LA is 0.02 meter by conductivity of A is 50 and area is will be same only, that is 0.025, 0.0225, 0.0225. Plus 1 by H. H value of A is 200, H into A 0.0225. So when you will solve this, you are going to get T1 minus 25 by, now this denominator is going to come as 0.24, 0.24. So this we have got QA. Now similarly we will be finding QB. QB means what? From the heater right hand side how much heat is going. So again I will be applying the same equation between the Tm and the T infinite. So Tm minus T infinite, and now it will be LB by KB into A plus 1 by HB into A. So Tm minus 25 by, now LB is how much? 1 centimeter, so 0.01 by KB. KB is 0.2 and area is 0.0225 plus 1 by, the heat transfer coefficient on both B side is 50, 1 by H 50 into area, that is, now area is same throughout because it is the case of slab, so no need to get surprised. Okay. So when you solve this, you will be getting Tm minus 25, it will be there, by, now this thing when you solve you are going to get as 3.111. This is equation 2 and the above is equation 1. Okay, so this is equation 2nd and this is equation 3rd. So you already know QA plus QB is 1000. Achha, one thing I have written here T1, it should be Tm. So now Tm minus 25 by 0.24 plus minus 25 by 3.11 is equal to 1000. So my dear friends, this equation when you solve this equation, you are going to get the Tm value or the T maximum, Tm or T maximum as 247.81 degree centigrade. 247.81 degree centigrade you are going to get. So my dear friends, this was the question which is asked, that find the maximum temperature of the system. Now he could have also asked you that find the TA and the TB. If it could have been extended this question, then I could have also added that find the TA and the TB. Now in that case it would be, once you get the maximum temperature, you can apply the same conduction equation and you can get first QA, QB, and then correspondingly T and TB you could have got. That is not the big deal. But one thing where you can get confused is that it is some conventional generation type question, heat generation, which is not. In heat generation, generally they will be mentioning that heat is being generated and it is expressed per unit volume type. So this is not that case. Here we are simply applying the the steady flow equations where the temperature profile will be linear. Here we are not considering that heat generation is taking place. So the temperature profile, if you ask me, that would be linear, not quadratic as is the case in generation. So this was the question which we have solved. I hope you have got, no doubt is there. Okay. So I hope things are getting clear. Let us move to the next question. Let us move to the next question. So anyone did? So what the question is saying, a very long cylindrical rod of 30 mm dia, 30 mm dia, so it's a circular section, is having one of its end attached to the wall maintained at 500 degree centigrade. Entire length of the rod is exposed to atmosphere at 25 degree centigrade with convective heat transfer coefficient of 25. Temperature along the length of the rod at x1 distance from the base is 400 degree centigrade and at x1 plus 10 mm distance is 390. The thermal conductivity of the rod is what? And consider the following relation this. So my dear friends, you know it's a fin question and you know that fins are very important as far as the conduction is concerned. But nowhere fin is been mentioned what I can see, but a long cylindrical rod, so you would understand by the language that he has given the fin equation, and this also you can understand. So you should be thanking the examiner, or at least here that they have given you the relation that you have to use this. Else generally you would consider from here that when he is mentioned the word very long, so that means it's a case of infinitely long fin. You know that in the fin there is total of 3 cases: infinitely long, then insulated tip, and then the general case where convection is taking place from the end. All the 3 you have to do. So, let us talk what he is asking. He is asking the conductivity of the rod. So, one thing is clear, the conductivity of the rod is hiding in this m value. So, when I get the m value, then only I will be able to calculate the conductivity. That is also there, very good. So, now how to calculate the m value? So, now we have to use the relations which is saying that at first let me draw the figure, then only things will be clear. So, this is the end or the base we say, and through here a fin is being attached, which is, I should use the next page. So, this is the cylindrical fin which is there, 30 mm dia. So, the dia is 30 mm. The base temperature over here is 500 degrees centigrade. Entire length is exposed to ambient is 25. And temperature along the length at x1 is 400. So, this is that x1, let us say, this is that x1, and let me assume that this is that x1 plus 10. So, at x1, and this is x1 plus 10, at x1 the temperature is 400. So, at x1 the temperature is, at x equal to x1, the temperature is 400 degrees centigrade, and at x equal to x1 plus 10 mm, obviously the temperature would be less, because when you go along the length, the temperature of the fin decreases. So, the temperature is 390, the temperature is 390, and which relation is saying to use? T minus T infinite by T naught minus, or Tb, we can say that the base temperature is equal to e to the power minus m into x, e to the power minus m into x. Okay. So, let me use the two boundary condition. This is the boundary condition 1 and this is the boundary condition 2. So, what I can say, if I use the by 1, what I can say, that the temperature is 400. So, 400 minus infinite is 25 by base temperature is 500 minus 25 is equal to e to the power minus m into x1, m into x1, and then using the, let us say this is your third, and what I can say, using the second equation, it will be 390 minus 25 by 500 by minus 25 is equal to e to the power minus m into, now x1 plus 10 I will not write, I will write 0.01. This is the trick over here, that why I should write 0.01. I need to convert into meter, because anyway all the m value, in the m value you will be substituting with the SI unit. So I have to substitute meter. Very good. So when I divide 3 by 4, then what we can do? So this is 375 divided by, 365 I can say, e to the power minus m x1 by, and this I can write e to the power minus m x1 into e to the power minus m into 0.01. I can break in this way, so that this and this gets cancelled, and this becomes e to the power m into 0.01. Obviously this will be something, and if I take log on both the sides, I have to take the log on both the sides. So ln 375 by 365 is equal to m into 0.01, because ln e will be 1. So this becomes very easy to solve, my dear friends, and when you solve it, you will get the m value as 2.703. You will get the m value as 2.703 per meter. Okay. But this was not the question. The question is find the thermal conductivity of the rod. So where I would get the, so how would I get? So clearly you know that m also he has given, that m value is HP by Ka. Now it's a circular cross section. So circular cross section, so the diameter is d. So perimeter by area will be, what is perimeter? Pi into d, and what is area? It will be pi by 4 into d square. So it will be 4 by d. It will be 4 by d. Perimeter by area will be 4 by d. So m value is 2.703 is equal to root over of h. So h value is 25 into p by d is 4 by, p by a is 4 by d, and d value is 0.03. And K value I do not know. K value I do not know. So everything I have substituted in SI unit only. So finally when I solve this, that means if I square both the sides, 2.703 whole square is equal to 20. So when you solve this, this will give you the K value. This will give you the K value, and this will come out to be 456.28 watt per meter Kelvin. 456.28 watt per meter Kelvin, right? So this is how we will get the value of the thermal conductivity, okay. And once you get the thermal conductivity, once you get the m value, literally he could have also asked you that find the value of x, or you can ask you anything. Once you get the m value, he can ask you literally anything, that find the temperature at this distance, find the temperature at that distance. So it's such a question which is based on the temperature profile and not your conventional FINF problem, where generally he would ask you that find the heat transfer, find the steady state heat transfer, which he asked you in a general FIN question, right? So I hope you understood the question. Okay. One more thing, please remember the temperature profiles, because they are very important. Now this is the case for infinitely long, but if you would have given you the insulated tip problem, then the profile would have been the cos hyperbolic, like theta by theta naught equal to cos h ml minus x by cos h ml. So that hyperbolic equation will come into picture. So please keep in mind the temperature profiles. Okay. Chalo. So let's go to the next question. So till now we have discussed the conduction problem, and I hope that those questions are going to be very useful for you. So I am giving you now, this is a long convection problem. So I please try to get this question. Okay, please go through it. So anyone is trying? Did you understood the question? So what the question is saying, water, and now it's, yes, seeing the question we would feel that sir, let's leave this question, but I'll tell you, my dear friends, convection chapter has one of the most, one ways most of the questions can be solved in a particular method, and you would know that finally what he is going to ask, and there is one approach only, literally one approach is there. Yes, some extra concepts you have to remember, some extra formula you have to remember, but it all is in one way only. I'll tell you how. Let me solve this question and then I will tell you that how they are all in a same way. Okay. Water at 20 degrees centigrade flow normal to the axis of a circular tube with a velocity of 1.5 meter per second. Okay. The diameter of the tube is 25 mm. Calculate the average heat transfer coefficient if the tube surface is maintained at a uniform temperature of 80 degree. Also estimate the heat transfer rate per unit length of the tube. Properties of water at the mean temperature is given, mean fluid temperature is given as this. Specific heat, kinematic viscosity, thermal conductivity, Prandtl number, density, viscosity at 80 and viscosity at 20 degrees centigrade is given, and use the relation which you can see at the bottom of your screen. So, my dear friends, what is the scenario? Let me explain you that there is a tube. There is a tube, and so I am taking the cross section only. So, let me try to draw in 3D. This is the tube which is given, and axis of the tube will be, the axis of the tube will be in this way. So, this is the axis of the tube in dotted, and he is saying that normal to the axis water is flowing, normal to the axis. So, normal, this is the axis, not along the axis, normal to the axis. So, can I say that it is flowing along this way? What air is flowing? Water is flowing. So, water is flowing along this way. Water is flowing along this way. Water is flowing along this way. Obviously, internal flow it is not there, it is the external flow. It is the external flow along the, over the surface of the, over the curved surface area of the cylinder, water is flowing. Velocity is 1.5, velocity u infinite, velocity is 1.5 meter per second, and the T infinite is 20, T infinite is 20 degrees centigrade. Normal velocity, diameter of the tube is 25 mm. So, dia of the tube is 25 mm. Calculate the heat transfer and calculate average heat transfer coefficient H value. Tube is maintained at 80. So, the surface area of the tube is maintained at what? 80 degrees centigrade. Very good. And estimate the heat transfer. Okay. All the properties when and if it will be required, we will come. Now, see my dear friends, it is a case of external flow first of all. Now, in external flow, in heat transfer, generally we will study the flat plate only. Yes or no? Flat plate we will study, and we will remember that if the Reynolds number is less than 5 into 10 to the power 5, the flow is laminar, then we will use one equation, and when it is turbulent we will use another equation, but this is a case of tube. So, no need to panic, already he has given you the Nusselt number equation, very good, and you know that H is going to come, heat transfer coefficient is going to come from the Nusselt number only, and once H is come, in any convection question if he asks you the Q value, that is the heat value, you will have to use HA delta T. What is A? A is the surface area, delta T will also be given, and H value you have to get from the Nusselt number. So in any convection problem, this is the only process. One Nusselt number equation will be there, H value you will get from there, H surface area you need to determine, Hi delta T will be gone. So all the struggle is there only till H value. Very good. Now in the equation that he has given, I hope you can see it is there in the bottom of your screen. You would feel that, sir, whether it is a free convection or forced convection, that doubt you might get. So see, in the equation of Nusselt number, he has given Reynolds number, not Grashoff's number or Rayleigh number. So if that would have been the case, Rayleigh number, then I would have told that okay, it may be a case of free convection, but since Reynolds is given, it is a case of forced convection. So one thing is clear, all the value mu infinite, mu w, all Prandtl number is also given. If I yes, Prandtl, the first thing is you have to get the value of Reynolds number. On getting Reynolds number, I will substitute over here. I will get Nusselt number. From Nusselt number, I will be getting the value of H. From H, I will be getting the value of heat transfer. That's it. That's it. Okay. So Reynolds number is rho V LC by mu. Rho V LC by mu, and in the question is given new value, so I will be writing u infinite LC by nu. I can write. Now nu and u infinite he is given, but what is LC? My dear friends, let me take some time and tell you that LC is the characteristic length. Now this characteristic length you study at so many places, right? In this case, external flow, remember in external flow it is the flow along the length. It is the length along which flow is occurring. So in the flat plate, the flow occurs along the length of the plate, so we take characteristic length as L. This is the tube. Now what is the characteristic length? The length of the flow is the diameter only, external flow, right? So LC will be what? Diameter. So u infinite, the diameter by nu. Now u infinite is what? 1.5, and dia is what? 0.025, and nu value he has given as 0.568 into 10 to the power minus 6 into 10 to the power minus 6. Now all this value when you will put, you will get the Reynolds number as sum 66,021.12. Now I don't know and I need not know whether the flow is laminar, whether the flow is turbulent, because this is not the case of flat plate that you will compare with 5 into 10 to the power 5. So it is the case of circular tube, so conditions may be different. But what I will do, I will take this equation and I will simply substitute it. Now what is the equation? Let me just take it to the next page. Okay, so I think some issue is coming. Anyway, so let me write the equation only. So this is no, just a minute. So Nusselt number is 0.4. Now what is the Reynolds number? The Reynolds number we have calculated is 66,021. 66,021 to the power 0.5 plus 0.06 into Reynolds number to the power 2 by 3, and Prandtl number is given as 3.68 to the power 0.4 into mu infinite value he has given is 1.006 into 10 to the power minus 3, and mu w value he has given is 3.5 into 10 to the power minus 4. So no need to lose sleep over it. Clearly you can see that all the values he will be giving to you directly. You will have to just substitute, see and substitute, and when you solve this you are going to get Nusselt number as 438.84. 438.84 is the Nusselt number. Very easy. When you get the Nusselt number, it is all but hd by k. hd by k. So Nusselt number is 438.84. H value I have to find, d value is 0.025, and k value he must be given, that is 0.6395. So from here what you will get the H value 11,225.53 watt per meter square Kelvin. So H value, once I get the H value, heat, Q value also I can get very neatly. So Q value will be what? HA delta T. HA delta T. So Q value I have to find out. H value already I found out, that is 11,225. 11,225. Now A is what? A is pi dl. What is the surface area? The convection heat transfer is taking place along the surface area. So pi dl, pi, and d is what? 0.025, and L, I don't know L, so he is asking per unit length, and delta T is what? 80 minus 20. 80 minus 20. So he is asking Q by L answer, that is per unit length he is asking. So if you put all these things, you are going to get close to 53 kilowatt. You are going to get close to 53 kilowatt. 53 kilowatt. Okay. So my dear friends, yes, in convection there is flat plate, there is external flow, then internal flow, and then there is free convection. In internal flow there are two cases, constant wall temperature and flux temperature. In almost all the cases, what he will ask you? He will ask you the heat transfer. For heat transfer you need H value, HA delta T. In any convection problem, we will do one more. There is HA delta T. Area generally you will be knowing, delta T you will be knowing. What you will not be knowing? H value, and for that only Nusselt number equation is there. Yes or no? Now Nusselt number equation is only different for different cases. What you have studied and what you have memorized, that is for the flat plate. This question we did, this is not the flat plate, this is for tube, cylindrical tube, right? After that internal flow will come. You have, for laminar the Nusselt number is constant. For turbulent we use Datus-Belter equation, which is there one equation. And in free convection, Nusselt number is dependent on Grashoff's number and Prandtl number. So instead of Reynolds, now Grashoff will come, but the approach is same. First Nusselt number, then H, and then the Q value. One more thing, my dear friends, there is characteristic length in most of the, in equations that you will see, there is characteristic length. So this is the case of external flow, and in external flow the characteristic length is the length along which flow is occurring. So flat plate hai, to use the length of the plate. diameter is there, so put the diameter, or in whatever might be the flow is taking place along what direction. But if it is the internal flow, then the characteristic length will be 4 AC by P, 4A by P, that is a 4 into cross sectional area by perimeter, 4A by P. So whatever is the case, internal flow is there, so 4 AC by P. Now now generally we will study pipe, because pipe is very favorable and very famous, but duct can also come, rectangular duct can also come. So approach will be same, but 4 AC by P will be the characteristic length. Now whether in Reynolds number, whether in Nusselt number, wherever you apply, that is 4 AC by P only what you are using. But don't forget, in bio number, that characteristic length is volume by surface area, volume by surface area. Okay. So again, in free convection when we talk, the characteristic length you have to memorize. For different cases there is different formula. So my dear friends, where approach is same in all the cases, but where he can harm you, or where you can commit the mistake, is if he gives different cases for characteristic flow, characteristic length. This is where you can get trapped, and this is where you should just learn all the cases, that what is the different of values for in case of characteristic length. Okay. Let us see, more questions will come, so we will get to know from there also. Chalo. So I hope this question is clear. He was finally asking me what is the, first calculate the heat transfer coefficient, we calculated, and then he is asking what is the heat transfer per unit length, that also we calculated very neatly. I hope no doubt is there. Okay. So let us solve one more convection problem. One more convection problem is there. Chalo. I am giving you 4 minutes to solve this question. So what this question is saying, an electrically heated sphere of 1.5 centimeter dia is cooled in a quiescent medium, quiescent means stationary medium, of air at 315 Kelvin. In order to maintain the surface temperature of the sphere at 385 Kelvin, estimate the amount of heat to be supplied by the electrical heater. Very good. He has given the D value, he has given T infinite, okay. The properties of air he has given at the mean film temperature, then viscosity he has given, Prandtl number also he has given, conductivity value. So very good. Beta he has given, so it's a case of free convection, and use the relationship finally he has given. So it's a case of free convection. How we can understand? Because he has given the beta value, and Rayleigh number he has given. In Rayleigh number is basically the product of Grashoff's and Prandtl number. So approach will be same. First I will be calculating H value, then I will be calculating the Nusselt number, and then I will be calculating the amount of heat which is needed. Okay. So what is Grashoff's number? Grashoff's number is G beta LCQ, G beta delta T, G beta delta T LC cube by nu square. So G is 9.81 and beta is already given 1 by Tf. So 2.86 into 10 to the minus 3. 2.86 into 10 to the power minus 3. And what is delta T? Now my dear friends, the sphere is at 315 Kelvin. The sphere is at, this is the sphere, and the dia is 1.5 centimeter. 1.5 centimeter is the dia. Okay. So my dear friend, G beta is there, and he is given that 385 and 315. So the temperature of the sphere is 385 and the medium is at a temperature of 315 Kelvin. 315 Kelvin. So my dear friends, one more temperature you can see, that what is T infinite. So always we should consider the immediate surrounding. Always we should consider the immediate surrounding, that is the quiescent air. Far temperature, let it be anything, that we don't care. So these two are the temperatures that we have to consider. So delta T will be what? 385 minus 315. And LC cube in this case will be again the diameter. Again the diameter, yes, it will be diameter. So 1.5 into 10 to the power minus 2 meter. And this case we have to memorize, there is no other option. G beta, the LC cube, so this cube we are writing G beta delta T LC cube, and nu square. Now what is nu? Nu is 2.076 into 10 to the power minus 5 nu square. So when you calculate this, all this when you calculate, the Grashoff's number we are going to get is 15,379.8. This would be the Grashoff's number. This would be the Grashoff's number. So now there are many ways which you can approach the problem. Nusselt number equation he has given to you, that use which relation? 2 plus 0.43 Rayleigh number to the power 0.5, Rayleigh number to the power 0.5, 0.25. So if I substitute over here, it will be 2 plus 0.43, and what is Rayleigh number? Rayleigh number is a product of Grashoff's and Prandtl. So Grashoff's I am writing 15,379.8, and what is Prandtl number? Prandtl number is 0.697 to the power 0.25. So when you evaluate this, the Nusselt number will come around 6.375. When you get Nusselt number, you know that Nusselt number is equal to H LC by K. In this case, it is D by K. So Nusselt number is 6.375. H value I have to find out. D is 0.015 and K value is 0.03. So H value we will get from here how much? 12.75. 12.75 watt per meter square Kelvin is the H value. And when you get the H value, finally you have to evaluate what? When you get the H value, so Q is equal to HAS delta T. So H value is 12.75. Area will be what? Sphere. It's a sphere. So 4 pi r square. 4 pi r is what? So that is 0.015 pi 2. 4 pi r square HA, and delta T is what? 385, that means 70. Delta T is 70. So when you evaluate the Q, it will come around 0.631 watt, 0.631 watt, 0.631 watt it will come, 0.631 watt, 0.631 watt it will come. So my dear friends, these in the last two questions that we have taken, the pattern is same. One is of forced convection and one is of free convection. One is forced and one is free. So the pattern you are seeing is same. What is the pattern? First calculate H, then Nusselt number, and then you get the value of the heat transfer, right? So this is what he was asking. I hope you got the solution. Okay. So let's now do, now convection we have done a lot. Let's now do one. Okay. Now internal flow question is there. Internal flow question we will do. Okay. Yes, this from this topic last year also came question. It's a very good question. Please go through it. So what this question is saying, a house built on a river, it's a very good question, so I gave an extra 1 minute. A house built on a riverside is to be cooled in summer by utilizing the cool water of the river, which flows at an average temperature of 15 degrees centigrade. Very good. A 15-meter long section of a circular duct of 20 centimeter dia passes through the water. Okay. Air enters the underwater section of the duct at 25 degrees centigrade at a velocity of 3 meter per second. Assuming the surface of the duct is at the temperature of the water, determine the outlet temperature of air as it leaves the underwater portion of the duct. The properties of air at 20 degrees C and 180 m is given as. So, this is a case of, now it is a very good question, let me draw the diagram first. See, this is the duct, circular duct. This is the circular duct, and you know the surrounding water is touching this duct. The surrounding water is coming in contact with this duct, and let us say this is the entry of the air which is flowing, and this is the exit of the air which is flowing. Through this air will flow. So, what is the temperature of the surrounding? 15 degrees centigrade. So, this is 15 degree centigrade. 15-meter long section of the, so 15 meter, the length is how much? 15 meter. Duct of 20 centimeter dia. So, dia is how much? 20 centimeter. Centimeter dia passes through the water. Okay. What is the velocity? 3 meter per second. So, u infinite I can say is 3 meter per second. The air is flowing, and air enters at 25. So, 25, air enters at 25 degrees centigrade. So, air enters. So, I can say that the mean temperature of inlet is 25 degree C. Assuming surface of the, now this is very important, assuming that the surface of the duct is at a temperature of water. So, throughout the duct surface is same as water. So, I can say it is a case of constant wall temperature. Constant wall temperature. Determine the outlet temperature of the air, that means TME, as it leaves the duct. So, we have to determine what is the TME. TME, that is the exit temperature of the air which is flowing. Okay. So, it is a very good question, it is a very good question, and you know so many things, so many places are there where you can commit the mistake. First of all, the formula itself you have to know. So, what is the formula? The formula will be, now you know that how we derive, and an exponential relation comes, and based on that last year question also they asked. So, exit temperature is, now it is a cooling case. So, T infinite plus T inlet minus T infinite, it is a cooling case, e to the power minus H A by m dot Cp, HA by m dot Cp, m dot Cp. So, this is the formula which you have to apply, and you know that from where it is coming. We derive by taking a element and we do the you know, the derivation you have studied, and the relation also you know that it is going to come in an exponential fashion, just that on that based on question, that concept only question is asked. So do I know the T infinite? Yes, I know it is 15. That is the water temperature. T inlet, yes, I know it is 25. T infinite, yes, I know it is 15. Now come to e to the power section. What is h? Yes, h also I know. Do they? No, h I don't know. H they have not given. H they have, obviously h they will not give in convection. Area is what? The surface area. So area is pi dl. Area is pi dl. Yes, I know the d is 15 meter. D is 0.2 meter and length is 15 meter. Cp value they must have given. Yes, 1007. Cp value is 1007 joule per kg Kelvin. Mass flow rate also they have not given me. Mass flow rate m dot value also they have not given me. So in this question, my dear friends, we have to evaluate, calculate two things. So one by one we have to see what is mass flow rate. It is rho into Q, rho into area into U infinite. So rho is what? Again rho I have to check. Rho I have to check. .204. What is area? Pi by 4 and diameter is 0.2 square. Pi by 4 d square. U infinite is 3. So when you substitute all these things, the mass flow rate you will get is 0.1134 kg per second. So out of the two things, one thing I already calculated, that is the mass flow rate. Now how to calculate H? How to calculate H? And they have not given any, what? Any Nusselt number equation also they have not given. So how to calculate H? So it means you have to memorize in this case, what is the Nusselt number equation. Okay, so first of all, but which Nusselt number to use, sir? Whether it's a laminar or a turbulent. So first you determine what is the flow nature, whether it's laminar or turbulent. So before that, Reynolds number you have to find. So many things are involved in this question. When you practice such questions, then only we get the confidence. When we practice such questions, then only we get the confidence to give the paper in a very brilliant way. So what is Reynolds number? It is rho u infinite LC by mu. So I think they have given the new value. So u infinite LC is a characteristic length. Characteristic length is for the internal flow 4AC by P. 4AC by P when you do, you will get diameter. See 4AC by P. So 4 cross sectional area is pi by 4 d square. 4AC by P pi d. P is pi d. So d gone, 4 gone, pi gone. So we will get as diameter 4AC by P. So u infinite into dia into by nu. Now you put the value. What is u infinite? 3. What is diameter? 0.2. And what is new value? 1.516. 1.516 into 10 to the power minus 5. So when you evaluate this, the Reynolds number you are going to get is 39,577.83. 39,577.83. Now my dear friends, you know it's a case of internal flow and it is pipe. So what is the what is the criteria for laminar and what is the criteria for turbulent. So, you know that when the Reynolds number is less than 2000, then we will say that it is laminar, but is it less than 2000? It is way more than 2000. So, it is so that means it is a sorry not 2000, it is 4000. If it is more, if it is less than 4000, then it is laminar. If it is more than 4000, it is turbulent. So, it is way more than 4000, that means it is turbulent. And whenever turbulent comes, you have to use a relation which is called as Dittus-Pilter equation. Dittus-Pilter equation, he has not given. Now, sometimes in the examination he can give you the relation also. He has given in the past, that means the examiner. Okay. So, since it is the flow is turbulent, so I have to say that since Reynolds number is greater than 4000, the flow is turbulent, and then we have to use Dittus-Pilter equation. So, where Nusselt number is 0.023, Reynolds to the power 0.8 and Prandtl to the power 0.3. Nusselt number is what? H d by k So, what is H? We have to find out anyway. What is D value? D value is 0.2 meter. What is conduct? Now, apart from H, everything he will give you. What is conductivity? 0.02514. 0.02514. Reynolds is 39577. 39577.8 to the power 0.8, and Prandtl number he has given. Prandtl number where? 0.7309. 0.7309. 0.7309 to the power 0.3. Okay. So, all the things he has given, you just have to calculate what is the H value. You just have to find what is the H value, and H value is 12.536. 12.536 watt per meter square Kelvin. Okay. So, my dear friends, H value we have got. H value we have got. H value we have got. M value also we have got. M value also we have got. So, everything we know in this equation, can we substitute? H value we have got 12.536. 12.536. M dot also we know 0.11. Can we substitute in this? Can we substitute, and we will get the exit temperature? Can we substitute over here? We will get the exit temperature. Exit temperature, we will get the exit temperature, and the answer is 18.53 degrees centigrade. 18.53 degrees centigrade. 18.53 degrees centigrade. Okay. So, my dear friends, I hope that after solving these questions, such type of questions, I am 102% sure that you will be very comfortable sitting in the examination hall. Clearly you are seeing the level of questions that we are discussing, and I am sure that you must have not seen this question earlier, or you might have not seen this type of question while practicing, right. Now you might see also, that is not the thing, but chances are there that you might have not come across such questions. Now when we do such tough questions, at least from the examination perspective, then we feel that yes, we have done something different from the rest. I know that when you see these questions, you might feel pain while trying to solve such questions, but this is what is needed. This is what is needed at the moment, right. Few questions we have solved and we get a very good all round approach of the chapter, right. So convection, by the last 3 problems I have just tried to cover many varieties, at least you might have got a very approach that how to solve convection problems, right. Chalo. So now should we move to radiation? Yes. Now my dear friends, from the shields, questions are questions, I am expecting questions from shield, my dear friends. Yes, shield I am expecting. So chalo, let's solve one question of shield, and here go. Okay. So my dear friends, what is this question? I hope that you have tried to solve. My dear friend, let me tell you that even if you are not watching this session live, later on when you completely revise your HT, then when you watch, I recommend you to watch this session, and while watching you pause at the question, try to solve within 5-6 minutes or 7 minutes also in some cases, and then you can match with the solution. But surely if you are coming across this video, I would highly recommend you to solve these questions, as it would boost your confidence, right? Chalo. So what is the question saying? An industrial furnace employs a hollow brick lining. Very good. The inside and outside surfaces of the hollow brick lining are maintained at 900 Kelvin and 430 Kelvin by placing the radiation shields in between the hollow space. The heat loss to the furnace surroundings at 300 Kelvin is both by radiation and natural convection. Very important statement. By sketching the arrangement, calculate what is the number of shields, not fields, which is needed. The emissivity of the walls and shields can be taken as 0.85. The convective heat transfer coefficient is governed by the expression which is there in the screen. Very, very good question. It will clear many doubts, my dear friends. Okay. So let us first try to sketch the scenario. So this is the wall of the furnace that I can assume. What is the temperature? 900 and 430. So this is at 900 Kelvin and this is at 430 Kelvin. My dear friends, let me tell you, in radiation, throughout the questions we will take temperature in Kelvin. Do not forget. Okay. In between this we are installing shields. In between this we are installing shields. How much that he has asked us to find? I don't know how much, I am just taking randomly, I am taking the shields. Okay. Then my dear friends, the heat loss to the furnace surrounding at 300 Kelvin. So furnace surrounding, say heat is flowing. So clearly I can say that from 900 to 430, that means from this phase, that means phase number 1 to phase number 2, the heat will flow by radiation, of course, and then from the second phase to the surrounding phase, which is maintained at 300 Kelvin, it is by both radiation and natural convection. It is both by radiation plus convection. Radiation plus convection. Radiation plus convection. Emissivity, and all the emissivity of wall shield he is saying to take as emissivity everywhere, he is saying to take as 0.85. So I can say that he has reduced my calculation. The question has in a way reduced my calculation because same emissivity he has given, and he is saying that you can calculate the heat transfer coefficient by this equation, H equal to 1.5 delta T 0.33. H is equal to 1.5 into delta T to the power 0.33. Very, very good question, and he is asking that for achieving this setup, what is the number of shields which is required? This is the question, my dear friends. What is the number of shields which is required? Number of shields which is required. Okay. So my dear friends, see one thing, he is asking you the number of shields. Okay. Now obviously it is a steady state setup, steady state flow, whatever heat is flowing from this phase to this phase, from this phase also the same heat will flow. Now one thing I know, that at the surface number 2, heat is flowing or transferring both by radiation and convection. So can I say Q, can I find the Q? I can say that at the surface the Q is both by radiation and Q is also by convection. So what would be the radiation Q? Sigma A epsilon T2 to the power 4 minus T ambient to the power 4. What about Q convection? H A and delta T. Delta T is what? T2 minus T infinite. Now I think A is not given. So if A is given in the question, A is not given, so I would calculate per unit area, that is not the thing. But I can find all the, I know all these values. So Q will be what? Sigma 5.67 into 10 to the power minus 8. Epsilon, he is saying that the good thing is that epsilon he is saying to take one same, that is 0.85. And T2 is what? 430 to the power 4 and 300 to the power 4 plus, now for H he is not given straight away, he has given some relation. So 1.5 into delta T is 430 minus 300 to the power 0.33. A I don't know, and T2 is 430 minus 300. So my dear friends, when you calculate this, so you will be getting Q around 229.24. 229.24, that is the watt. 229.24, that is the watt. So this is the steady state heat flow that I have calculated. Steady state heat flow, and this is the same. What is the meaning of steady flow? That is the same heat which is flowing throughout the system. Same heat which is flowing throughout the system. Now you know that I have to apply. Now see, this is the heat which is flowing after application, after installation of shields. This is the heat that is flowing after the installation of the shields. So sigma, what is the heat between two slabs? Sigma T14 minus T24 by, now 1 by epsilon 1 plus 1 by epsilon 2 minus 1, but if the epsilons are same, so it will be 2 by epsilon minus 1. But this is for when no shield is there, but now shields are there, just I don't know how much. So simply you would divide by n plus 1. Simply I would divide by n plus 1. So this is what, this is the entire heat transfer when n number of shields are being installed or placed between the two phases. This thing you people are able to understand, and this heat is only that we have calculated 229.24. Clear? This is the concept. What a question, very good question this is. Okay, sigma 5.67. T1 I know, so 904 minus 430 n I do not know, and 2 by epsilon is 0.85 minus 1, and that is the same as 229.24. So, my dear friends, everything is there except capital N. Everything is there except capital N. Everything is there, and when you solve this, you would approximately get n value to be as 11. You would approximately get the n value to be your 11. You would get 10.7, but that would be, 11, close to 11. 10.7 is nothing, 11. Got it, my dear friends? Got it, my dear friends? Got it? Very, very good question. Very, very good question, my dear friends. Let me tell you that in radiation, generally two surfaces they will give you, and after the two surfaces they will ask you that what is the heat transfer between them. So, the topic radiation networks, see, everything in heat transfer is important, that is not even a debate, everything we have to do. But among that also we can say that from radiation network, that is the heat transfer, radiation heat transfer between two enclosed surfaces, that is one of the most favorite area from where questions are very high chance that they will ask you. So, that the similar type of question I took in last year GATE score booster session, you can go and watch now also, it must be there. The same question, more or less the same question came in GATE. Okay. So, that is one thing. So, that people have seen, so I have not covered in this session. Now, Shields question is what I feel is that is something due for GATE to set a question in that topic. So, I feel that Shields question is literally I think somewhat unexplored. So, from there questions have a good very high chance of coming, and generally students would just prepare that, know that okay, this is Shield, but generally they would not prepare that much of question. So, I hope that you are getting this thing, okay. So, I hope you are enjoying the sessions. In case if you are enjoying, do press the like button. In any doubt you can post your comment also, I will personally answer. Chalo. Chalo. So, radiation, this is the case of radiation. Chalo. So, between two, now I have the question over here, it is kind of new only. So, let us solve this also, the rate of heat transfer, this in a different fashion it has been framed. Chalo. Chalo, I am giving 4 minutes for this question. So what this question is saying, a cubical oven has inner sides equal to 0.4 meter. Very good. One of the faces of the oven forms the door. Okay. If the 5 other inside faces are black and maintained at 600 degrees centigrade, find the rate of heat loss if the oven door is kept open. Stephen constant is given. Okay. So let us try to sketch the the diagram. Cubical he is saying, so chalo, let us try to, I have drawn cuboidal kind of shape, but it will give you an idea. So I hope you are getting the figure. How many faces are there? 6 faces are there, and the side of each of the 6 faces is 0.4 meter. So the side is 0.4 meter. What is the size? 0.4 meter. 0.4 meter. One of the faces of the oven forms the door and rest are black, maintained at 600 degree. So I am assuming that this one is forming the door, this one is forming the door, this one is forming the door, and this is the 5th surface, this is the forming the door. Rest 5 are black and they are maintained at what? 600 degrees centigrade. Rest are maintained at what? 600 degree centigrade, and they are black. Okay, find the rate of heat loss. My dear friends, from the 6 faces, see, they will try to exchange heat within themselves, and they will also let some heat go out of this 5th one which is kept open. So one thing is clear, that we need to have the shape factor. We need to calculate the shape factor of from 2. Let's say I am assuming that, you can assume anything. Let's say I am assuming that this is the one. The 5 surfaces are constituting one complete surface, and the door I am assuming that it is 2. So what I need to find? I need to find what is F12, because I know that all the heat is not going. That is the number 1 thing. Okay, and then the number 2, I will be using the Stephen Boltzmann simple equation, that if a surface is there, what is the heat? Sigma A epsilon T to the power 4. Simple, I will use the how much heat is going. But first I need to calculate 512. So 5 surfaces, A1 will be what? 5A square. 5A square, and A2, if I consider this as the A2, that if door was there, how much heat would have been went through that? So that will be A square. Acha, clearly F21 will be 0, F21 will be 1, F21 will be 1, 2 to 1 will be 1. So I can use the reciprocity relation, that A1 F12 is equal to A2 F21. I can use this. What is A1? It will be 5A square. F12 I need to calculate. A2 is how much? A square, and F21 is 1. So one thing I can say, that F12 will be what? 1 by 5, and 1 by 5 is nothing but 0.2. So one challenge is achieved, that is F12 I know. And now I can very easily find that what is the rate of heat. It is, I can simple say that if I know how much portion of heat is going, that is 0.2. So if a surface is kept, if a surface, how much it will be emitted? How much heat will be emitted through the surrounding? Simply I will use the Stephen Boltzmann equation, sigma A T to the power 4. Simply I will use the equation sigma A T to the power 4, sigma A T to the power 4, but don't forget that I have also calculated the shape factor. Don't forget I have also calculated the shape factor, shape factor, shape factor. Is it clear? Is it clear? Okay. So sigma, all the values I will be simply substituting, that is 5.67 into 10 to the power minus 8. Area is 5 a square is 0.4 square, that is 0.16. T to the power 4, obviously in Kelvin, 600, 273, 873 Kelvin. So 873 to the power 4 and safe factor is 0.2, 0.2. So this will give you the answer. This will give you the complete answer, which is coming as 5269.386 watt. This is the answer that we are getting. This is the answer that we are getting. This is the answer that we are getting. Okay, calculations, you can do it on your own, that is not a very big deal, but the concept which is there, you have to understand that concept. Okay. So I hope you got the concept, and we have covered this question also. So in radiation I have covered the shields concept I have covered, and this radiation heat exchange concept also I have covered. Okay. Chalo. So let's move on to the next equation, and next equation, my dear friends, radiation we have covered, conduction we have covered, convection we have covered in detail, and now my dear friends, through one question we will cover the entire heat exchanger. And this question is very good question. I can promise you that in this question only, all the methods, we will solve this question by two methods itself, by both the LMTD NTU method, LMTD method also, and effectiveness NTU method also. So please try to do this question. You know that one heat exchanger question is a must in GATE. Chalo, let's solve this question. So my dear friends, what the question is saying, a counter flow double pipe heat exchanger. So one thing is clear, it is a counter flow heat exchanger, okay, is to heat water from 20 degrees centigrade, so 80 degrees centigrade, okay, at the rate of 1.2 kg per second. Very good. The heating is to be accomplished by geothermal water, which is available at 160 at a mass flow rate of 2. Very good. The inner tube is thin walled and has a diameter of 1.5 centimeter. Very good. If the overall heat transfer coefficient on the side of heat exchanger is 640, what is the, determine the length of the heat exchanger required to achieve the desired heating, and specific heat of water is 4.18 and specific heat of geothermal is 4.31 respectively. Okay. My dear friends, it's a straightforward question that is if you have solved PYQs, so you would get an idea that how to approach this question. But I will show you that how you can solve this question by two methods. In a heat exchanger, we study two methods, LMTD method and the effectiveness NTU method. So see, LMTD method. So clearly I can apply the energy conservation that Q is equal to mass flow rate of water, Cp of water, mCp, T water exit minus T water inlet, and that is equal to m dot of hot, Cp of hot, that is geothermal, and T hot inlet minus T hot exit. So mass flow rate, I think he has given 1.2, and Cp of water is 4.18. Water inlet and exit is given 20 to 80, so 80 minus 20. Mass flow rate of hot also it is given, it is 2, and Cp of hot is 4.31. T inlet is given as 160, and T exit I don't know, which I have to find. So when you solve this, you will be getting THE, as 125 degrees centigrade, 125 degrees centigrade. So all the four temperatures I know, and in LMTD we need that only. All the four temperatures I know, and in case of LMTD we need that only. So geothermal is having an TH inlet is 160, TH exit is 125. So since it is counter flow, so TCI is 20 and TCE is 80. So I can say that delta T1 is 80, clearly this is the delta T1, delta T2 is 105. So what will be LMTD? LMTD or delta T mean, formula is what? Delta T1 minus delta T2 by ln delta T1 by delta T2. So when you substitute, when you substitute you will be getting LMTD as, when you will substitute you will be getting LMTD as 92 degree centigrade, 92 degree centigrade, 92 degree centigrade, 92 degree centigrade. And once LMTD is known, you can very well apply Q is equal to UA delta Tm. UA delta Tm I can apply. So what is Q? Q I can very easily find out. Q I can very easily find out 301,000. 301,000. U value he has already given. The Q value how I can find? MCP delta T. Any one MCP delta T you find, this is going to give you Q na. Okay. U value is how much? 640. Overall heat transfer coefficient is 640. Area I have to find out, which I don't know, and delta Tm we have found out 92. So this would give you the area. This would give you the area, which you will get as 5.11 meter square. And now he is asking the length. Now he is asking the length. So what is the length of the heat transfer actually? In convection, we take the surface area. So what is the surface area? Pi dl. Pi dl. So he must be given the diameter 1.5 centimeter. 1.5 centimeter. So 1.5 by 100 meter. And length you will find out. Length we will find out very easily. We can find the length. So when you substitute all those things, you will get length as 108 meter. 108 meter. 108 meter. 108 meter is the length. 108 meter is the length. Okay. So yes, the approach is very straightforward. I am not saying any rocket science I have applied, very straightforward concept. But how to solve this? By effectiveness NTU method. Effectiveness NTU method. Effectiveness NTU method. See, first what is the roadmap? First I will calculate the C, which is the ratio of C lower by C higher, C minimum by C max, C lower by C higher. Number 1. Then I would calculate what is effectiveness. Very good. Then I know that effectiveness is a function of, NTU is a function of, NTU is a function of effectiveness comma C. So I would apply one relation for counterflow and I would get NTU, and in NTU it is hidden UA by m dot Cp, which is of lower. So from here I can get A, and when you know A, you can get very easily what is the length. Clear? Clear? The approach is clear. So when you find the C of water, and all the values are given to you, when you find the C of water, you would get as 5.02. When you find the C of geothermal, that is the MCP. What is C water? What is C of water? That means we are finding m dot Cp, m dot Cp for water. All the things is given to you. So you would get as 5.02. When you calculate the C of geo, that is geothermal, you would get 8.0, 8.62. So can we get C? C is the ratio of C of lower, that is water, by C of geothermal. So that you will get as 0.583. Will get as 0.583. 0.583. Okay. So can we get Q actual? See, Q actual we already know, na? mCp delta T of water, if you find, and actually we already have calculated 301 kilowatt. But the thing is, how to find Q max? Q max is mCp lower, over here it is water, into TH inlet minus T water exit. So mCp lower is 5.02, THI is 160 and TH is TH inlet and TC inlet. TC, that is cold water inlet, not exit, inlet. Okay. So that is 160 minus 20. When you solve this, you will be getting 702.8 kilowatt. 702.8 kilowatt. 702.8 kilowatt. So effectiveness is what? Effectiveness is Q actual by Q max. Actual is 301 by 702.8. So what is effectiveness? We are getting 0.428. 0.428 we will be getting the effectiveness. Now you know that for counter flow, we have a relation that NTU is, now you are required to memorize this. All the value you know, effectiveness C, all the value you know, when you substitute you will be getting NTU as 0.651. You will be getting NTU as 0.651. And this NTU is only equal to UA by MCP small. You know NTU, you know MCP small, you know, so area you can find out. When you know area, you can get pi d L, say you can calculate the length. Okay, I am not solving, you will get the same answer. You will get the same answer. So same question we have done by the NTU method and the effective and the LMTD method. And I hope that there is absolutely no doubt. I hope that there is absolutely no doubt. Okay. Absolutely no doubt. Okay. So yes, so all the 4 chapters I have touched, only conduction also I have touched. Conduction touched, convection done, radiation also done, and heat exchanger also done. One question I feel that, you know, from last year I am trying and I am solving this, and I feel that this case can come in your examination. This case can come in your examination. So I would recommend you to at least go through this question and then we will discuss the solution. We have done questions of convection we have done, but I would recommend you to just Just check once. Hello, Atul. So I hope that you have tried this question. See where he can trap you. He can there are three cases A, B and C. It's a case of free convection, so obviously Rayleigh number, Grashoff's number, Prandtl number, all those concepts will be there. That is, normal. But where actually you can get trapped? You can get trapped in the characteristic length. Characteristic length, only one thing I will tell you, characteristic length is when it's a vertical plate, the characteristic length is just the length over here, just the length over here. When it's a horizontal, then characteristic length will be AS by P. When it's a horizontal plate, it is AS by P, AS by P. Now it's a AS by P. Now what is, it is given that it is a square plate, it is a square plate. So what would be AS? AS will be, A square and P is 4A. So actually it is A by 4. Actually it is A by 4 or L by 4, whatever you want to say. Let me write L only, else you will get confused. So AS is what? L square and P is 4L. So actually it is L by 4. So yes, in both the cases, whether it is hot surface facing up, whether it is hot surface facing down, that is not the thing. But characteristic length is AS by P. Yes, you have to memorize this. There is no other option. You have to memorize this. In vertical, it is L only. Now in both the cases, process is same. There is no issue. See, you don't have to memorize for different cases. You don't have to memorize Nusselt number relation also. In this question, I have given the Nusselt number for case A, I will use this. Nusselt number for case 2, I will use this. Nusselt number for case 3, I will use this. All the questions, the story is same. What is Rayleigh number? Rayleigh number is nothing but the product of Grashoff's and Prandtl. So that also he has given. Prandtl number he will be given in the question. You have to calculate Grashoff's number. The story is same throughout. You just have to know that what is the characteristic length in each of the cases, right? For example, in this case, if you just find out, so first Grashoff's number you will be finding out, that is G beta, what is the thing? G beta delta T LC cube by nu square. G value 9.81, beta he has already given 1 by 333, 1 by 333. Delta T is what? Surface minus 90 minus 30. I can see from here 90 minus 30, that is 60. LC cube is the length. The length is 0.6 meter. So 0.6 cube. And nu is what? Nu is what he has given? 1.896 into 10 to the power minus 5. 1.896 into 10 to the power minus 5 square. Just find this Grashoff's number. When you solve this, the Grashoff's number will come out to be. Achha, one thing I can do directly, I can find Rayleigh number. It is nothing but Grashoff's into Prandtl. So this number only, Grashoff's number only, if I put the Prandtl number is 0.7202. 0.7202. So directly I will get the Rayleigh number, and Rayleigh number I will get around 7.656 into 10 to the power 8. 10 to the power 8. I will get the Rayleigh number. Once Rayleigh number is obtained, you can use this relation, my dear friends. Nusselt for A, for case A, that is Nusselt number is 0.59 into Rayleigh number to 7.656 into 10 to the power 8 to the power 1 by 4. To the power 1 by 4. To the power 1 by 4. Now it's a case of cooling, so 1 by 4. Okay. So you will get the Nusselt number as, from Nusselt number directly I can write HD by K. Nusselt number directly I can write HLC by K. HLC by K. HLC by K. Nusselt number directly I can write HLC by K. And over here it's the characteristic length, so it is not a pipe that you will write diameter, it is HLC. LC is L, just now we have discussed that LC is L, so L by K, and this side you know length is 0.6, characteristic length is 0.6, K value is what? K value is 0.028, 0.0208. This side you know directly you will get the H value. H value, when you solve this, you will be getting H value as 5.306. 5.306, and once you know H, same story everywhere. Today we have done many questions based on this. H value, once you get, Q is equal to HA delta T. HA delta T is 5.306. What is A? A is the surface area, that is square, so 0.36. HA delta T is 60. So you will get the Q value. Q value you will get around 115 watt. 115 watt. 115 watt. And next two cases, what is the only difference? The only difference is about only in the characteristic length, that is L by 4. So 0.6 by 4 will be the characteristic length, and same way you can do the other two as well. So my dear friends, no matter at whatever stage of your preparation you are, I am highly recommending you to don't go through the entire session, just check the questions, just pause at the questions, solve in your rough copy and check the solution or answer whether you are getting or not. If not, I have solved here, just see how I have solved. And I am saying you, this can be your final final set of questions you need to practice. You do whatever you are doing, you solve your PYQs, you solve your test series questions, all these questions you solve, but lastly do go through these questions, because last year only 2 questions from GATE score booster, similar questions directly have come in the examination of 2024, right? So go through it. I have taken 2 sessions, one for the industrial engineering, another for the heat transfer. In industrial engineering you must have seen all the questions were one level above the other, right? Here also you can clearly see that what kind of questions we are actually dealing over here. I am 100% sure that this is going to boost your confidence like anything. And not only these 2 subjects, TOM, engineering mechanics, production, thermal, all these GATE score booster sessions are happening, and do go through, do solve those questions. They are going to definitely boost your confidence, right? When we talk on heat transfer, these are some of the areas which we generally focus on. Anyway, you are solving your PYQs, you yourself know that 4 chapters are only there. We have to do those 4 chapters neatly, and we can definitely expect some 6-7 marks question from heat transfer. This subject can be one of your strong pillars, strong foundation on which you can get good marks. HT combined with industrial engineering, thermal, SOM, engineering maths, these are some of the areas where you can target some good marks. And of course you will be doing your TOM, you will be doing your production, I know you will be doing, but these subjects which I told, try not to leave them at any cost, right? Some topics here and there you can leave, but don't overall leave the subject. These can fetch you some good marks. In fact, don't leave anything, FM, MD, do everything, but these subjects particularly don't leave, right? So I hope you have enjoyed this session, and in case of any doubt in any of the questions, feel free to post your doubt. I'll be answering it. Chalo, so we'll be ending the session here itself. And few questions are which I have left, they are similar questions, so you can refer them for practicing. Okay. So my dear friends, as I said about the test series plus, do join it, and I am saying you, it can be your, the friend which is there for practice. It can be your best friend in these last 2 months, before gate, where you can practice a lot of questions. Test series may 120 130 plus test series are there, subject test, chapter test, and then along with that you are getting the gate question bank also. Don't forget, in gate question bank you will be getting 2 books, one for apti, one for your core subject, and you are going to enjoy like anything. So do join it, and in case of any doubt you can check below the link. You can ask the counselor for any help. So all the very best, my dear friends. This is our Telegram channel, you can join it. You will be getting daily live quizzes, and you will be getting the daily job notifications in case you don't want to miss. So do join it. Every time any important job updates, updates regarding MTech or government jobs, PSUs, you will be getting right after the official notification, right? So join it, and finally I'll be wishing you all the very best, my dear friends. These 2 months are very crucial. I know you are studying, there is no doubt, but try to focus your studies more in a numerical oriented fashion rather than the theoretical stuffs. Do practice a lot of questions, take a good sleep. Don't forget that health should be your first priority above anything. So do take a good sleep, relax, and trust yourself, right? We'll be coming up with many more sessions, my dear friends. Till then, stay tuned, keep practicing, and in case you are finding this useful, do share it with your friends also who are preparing for GATE. It might help them a lot. Take care. God bless. Jai Hind.